And this is number 8 on the review. On number 8, we're asked to graph some functions and then use the graph to identify domain and range. So if we look at part A, we have the absolute value of x minus 4. So I know that an absolute value graph is going to be V-shaped. So it's helpful if you can find kind of the bottom of the V. So whenever I set up my values for x, I like to start by figuring out what value of x is going to make that 0. So I know that that's going to be a positive 4. I'm going to put that sort of in the middle. So then that would be 4 minus 4 would give me 0. Absolute value of 0 is 0. So then what I would do is I would try to pick a couple of values bigger than 4, so maybe 5 and 6, and then a couple of values less than 4, like 2 and 3. Okay, so if I plug in a 2, that's going to be the absolute value of 2 minus 4, which gives me the absolute value of negative 2. And that's going to give me a 2. All right, and I'm just going to keep drawing that up here. Then I'm going to do the absolute value of 3 minus 4. That will be the absolute value of negative 1, which is 1. All right, so moving on to the 5. Absolute value of 5 minus 4. That one's a little easier. It's just absolute value of 1, which is 1. And then finally, absolute value of 6 minus 4. That would be absolute value of 2, which is 2. All right, so when I plot these, I'm going to plot the 4, 0 first. All right, and then I have the point 2, 2, 3, 1, 5, 1, and 6, 2. So that way I can see that nice V shape. So it always helps to know what shape you're starting with. Now I'm also asked to do domain and range. So remember, domain is my x values. So for domain, I'm thinking left to right. So if I look at my graph, I see that it keeps going to the left and it keeps going to the right with those arrows. So that means the domain is negative infinity to positive infinity. Now if I look at the equation doesn't have any denominators or square roots, so I don't have any restrictions on x. All right, now range is a little trickier. For range, I want to look low to high. And I definitely have a low value. So my lowest point is going to be right here. And that's the point 4, 0. So remember, for range, I'm interested in the y value. So the lowest my graph goes on the y-axis is 0. But then it keeps going upward. So it's going to keep going up in both directions. So it's going to go up towards positive infinity. All right, so let's look at part B. Now this one's a square root. So I know a square root has a shape something like this. So this one's a little trickier to pick values for. I want to do kind of what I did on the last one. I want to think about what value of x would make me get 0 under my square root. And that's going to be a negative 2. I'm going to put that kind of in the middle. So if I did negative times the square root of negative 2 plus 2, that would be negative times the square root of 0. That would be negative 0, which is just 0. Now, if I try to pick something smaller than negative 2, let's say I pick negative 3, I would get a negative and then the square root of negative 3 plus 2. And notice that's going to give me a negative under my square root. So that means that that value is not in the domain, because I can't have a negative under the square root. So that doesn't give me a point at all. So what that means is I can only pick things negative 2 or bigger. So if I try negative 1, that would be minus the square root of 1. That's just going to give me minus 1. Now if I pick 0, I'm going to get negative square root of 2. And I could put that in a calculator, but I would just prefer to stay away from ones that give me ugly numbers. So I could pick something like 2, because underneath my square root, 2 plus 2 would give me 4, and then that gives me a nice square root, so that would give me negative 2. So that gives me 3 good points. So if I go ahead and plot those, that's negative 2, 0, negative 1, and 2, negative 2. So remember, I can't go to the left of -2. So my graph has a definite stopping point right here. And this is upside down from what we were expecting, but that's because of the negative in the front. All right, so remember my domain goes left to right. So I have a very definite left endpoint, but to the right it keeps going on forever. So that is going to be the point -2, 0, and for domain I want the x. So my x's go from -2 to positive infinity. Now range is going to go low to high, so you have to do this a little bit backwards. So my low would be over here, but it keeps getting lower. So that's going to be negative infinity, but then it tops out here, but I want the y value of 0. So my range goes from negative infinity up to 0, including 0. All right, so now let's look at the last one. The last one's a cubic. So a cubic looks something like this. All right, so I'm going to start in kind of the same place with the others. I'm interested in what gives me a 0 inside my parentheses. So I'm looking here, and I know if my x is 1, then I'm going to get 1 minus 1 is 0, and then 0 cubed is 0. Let me zoom in on that. All right, so I should have probably put that in the middle. Let me move that. So I'm going to put that in the middle. So I'm going to pick a couple of numbers smaller than 1 and a couple of numbers bigger than 1. All right, so if I plug in 0, 0 minus 1 cubed, that'll be -1 cubed, which will be -1. If I plug in a -1, -1 minus 1 cubed, that'll be -2 cubed, which is -8. All right, so let me go erase this one. Now if I plug in a 2, 2 minus 1 cubed, that would be 1 cubed, which is 1. And if I plug in a 3, 3 minus 1 cubed would be 2 cubed, which is 8. And so that gives me a bunch of points that I can plot. Let me erase all this. All right, so I've got -1, -8, 0, -1, 1, 0, 2, 1, and 3, 8. So I can see that nice little curve. All right, so when I do domain on this one, it's hard to see, but it continues to travel to the left and to the right as it goes on. So my domain is going to be everything. Now it's a little easier to see low to high. We can see it definitely keeps going down, it definitely keeps going up. So my range is also -infinity to positive infinity.